Today is actually more of the same from 5.1, but it's better because actually the answer is going to be given to you, just like a geometric proof, right? Geometric proof, you get a little bit of what? Starts with a G and there's a V in the word. Given, and then it says after that, what? Prove. And what's prove? That's the answer. So what's important about a geometric proof? Not the answer, your logic that leads up to that answer. Isn't that right? Now, when I say geometric proof, that often inspires fear with the young adults, right? And it is a little bit as challenging as a geometric proof, but not really. It's the same stuff you've been doing, like what you did yesterday. If you had some success in some of those, simplifying and factoring of trig stuff. So first of all, the yellow is important. So I'll let you read that for a second. I'll pause the video. You leave the other side alone. You pick a side. There is no whatever I do to one side. Say it. There is none of that in this. Zero. All right. What you have to do is make a choice. I'm going to work with this side and turn it in exactly to the other side. So your last step is repetitive, and I'll show you what I mean by that. And I said I'm not going to write down what I expect you to do. You're going to listen and then hopefully take it to heart. This is why I told everyone, for the love of dog, what do I do? Don't show this message again. I hit that every time, and it always comes back up. Sorry for yelling at the computer, but a little unstable right now. All right, so I'm just going to paraphrase. How do we do this? Well, you've already done some of the things. Like, don't write this down. Don't even try. Okay? I'll write you up if you start writing this. All right. Remember your 5.1 identities. Sometimes it's a flat-out just replacement, plugging in. We okay back there? Okay. This is the smartest. It's easier to take more complicated and simplify it. So most of the times when these identities are presented, you have a complicated side equals one trig thing. Well, I'm going to make that complicated side turn into that one trig thing by what we've already done. So it's exactly the same thing you've been doing, except now you know what the answer is. All right, so understand that as well. This is a lot of the times, but don't be a robot and do this all the time. Changing everything in terms of sine and cosine is one of the most popular things that works. All right? And you'll see simple questions where that occurs. And then here's number 4, which what you did yesterday. Sometimes you have to factor, or sometimes you have to FOIL. Some algebra skills will be needed. Fraction work, substitution, Pythagorean identity, and then some common denominator work is what they say here. You could read this fully. We're kind of short on time. I want to get into the examples so you know exactly what we're doing and how I want you to do it. Okay, so let's talk about how this is supposed to look when you're done. Here's your piece of paper. Your homework's going to go like this. You're going to do 1, and you're going to do your work in columns, just like a geometric proof, right? And I will kind of give you some hints on how I want this to look. Then when you're done with 1, you'll put 2 here. Do your work in columns. No snake in your work like you've been doing the last couple assignments. Your work does not go across. It goes straight down. It's not a big deal because you know where you put 3? On the front right here, and then you do your column work. So that's how that, number 1, this is going to work, and I'll show you what I mean in the exact examples that we have. Okay, here we go. Wait, is that the first one? Yeah. Verify that each trig equation is an identity. What this means is this is true. They're not cheating you. They're not trying to trick you. So guess what? First of all, what looks more complicated, the left or the right side? So the left side is sine of alpha. It's all about you proving that it's sine of alpha by showing your work. Do you get it? So that's why this is better than 5.1 where it just said simplify, and then you didn't know when you were done. So work with the more complicated side. Leave this side alone. So this is how I want you to do it. With this being homework, you'll have to write this. So that's step 1. If you want to number your steps, go ahead. What I told my honors students is the next step is denoted by putting an equal sign on the correct side of what you're dealing with. So who are we going to work with? Left or right? Left. So we're going to work with the left side, and we're going to put an equal sign here. And what are we going to do? I don't have time for this. We should know what tan is, right? What's tan? Sine over cosine. If you don't like alpha, you can make it A. Over, what's secant? 1 over cosine. Okay, so now what does this equal sign denote? A step. That tells me I know that's your first step. If you want to put a 1 by this, I didn't have the honors do that, but that might be a good idea. Because you know what you have to concern yourself with? Satisfying Mr. Samuelis's happiness of looking at your work and being able to understand what you wrote and what a step is. If you don't do that, that's your fault. All right, what can we do right now, everybody? Cancel the cosines. Here's number 2, and I couldn't care less how you feel about it. You will always end an identity by writing, oh yeah, sine over 1 over 1 over 1 is sine, and that is exactly what it was supposed to equal, so draw an arrow and say I'm done. That arrow says I'm done. I don't even want you to rewrite this. I want you to drag this down like that and say, it's over, baby. I've accomplished it. This equals itself is always how you're going to end. You're not going to stop short on me on that. So here's our second example. I'll give you a chance to write it. Glad I put that on YouTube or online. Now these get weird because, you know, section 5.1 is about simplifying, but really what verifying identity is satisfying. Satisfying what's over here. And is this simplified all the way, yes or no? No, like what's 1 minus sine squared? What's 1 minus sine squared? Oh no. Because don't touch the right side though. So you have to understand that this is a little bit more complicated than this, right? You must leave this alone. You cannot turn this into 1 over cosine squared, then go over here. You can't go back and forth. You got me? So this must be left alone once you make a choice. You have 2 choices on this one. Wow. That scared me. It actually sounded like that was stereo. You could what? Now why am I choosing this? Because tangent squared times cotangent squared is what? 1. So this is tangent squared x, and I do appreciate that you wrote this as 1, knowing tangent squared times cotangent squared equals 1. And if you want to put that's your step 1 of work, go ahead. Don't need it as long as you put that equal sign. Student just asked, isn't 1 plus cotangent squared cosecant squared? Yes, that would have been a different path. All right? So there are options. What's tangent squared plus 1, though, everybody? What's tangent squared plus 1? Oh, tangent squared plus 1 is secant squared. And I don't need proof for this. And I'm going to tell you, it used to be worse. We used to Common Core this and have you write sentences why we did each step. That would be the reason, like a geometric proof. Do you want to do that? Do you want to do that? Well, then if you don't want to do that, do this. And then we're even. Is that okay? You got it? Now I can read this and say, all right, this student knows tangent squared plus 1 is equal to secant squared. Now what you should do is keep looking at the right side. Does anyone know what I should do next then? Yeah. And there's no skipping steps. Yeah. Equals. These are optional. They're a good idea for those that feel like they might be messy. Oh, by the way, slobs, people that don't write well, you better start trying to do better because I'm going to mark you wrong if I can't read it. Good morning. All right, then what's the last thing? What did I just say cosine squared is equal to? So the last thing you write is, 1 over cosine squared. Cosine squared is 1 minus sine squared. And lo and behold, this equals itself. Done. Hasta la vista, baby. Okay, I'm going to speed this up. Now, obviously, aren't fractions more complicated? So whenever you see a fractional side and a non-fractional, you're going to work with the fractional side more than likely. Okay. Now, I've actually brought this up quite a few times. Whenever you have fractions, and it's like one fraction, sometimes what's cool is to split this up into 2 separate fractions using the opposite of common denominator rule. And actually, you can do 2 steps in one. And I should have done that. because I want to tell you what's legal for you, what I will allow. What is tan? So you might want to write that as sine over cosine, then split this up into two separate fractions. Because look at this side. Isn't that what that side is? It's something minus something. All right, so if I split this up into two separate, then I'm on my way already. What's cotan? Cosine over. Do you see why I'm having you memorize these? You can't have to keep looking this up over and over and over again. It eventually has to sink in. Now, I would really appreciate if we could do this fast. This is why I've been trying to teach everyone fractions. Do you know who cancels in this first one? They're actually the signs. You can put this over 1 in your mind. So who cancels in the second one? The cosines, because they're both in the numerators of each of these little fractions. I would love that. And this is actually all within step 1. So what do we really do in step 1? Really 3 things. We separated the minus sign, the two fractions. We canceled the signs, and we changed sine, cotan, and tan. And it's all legal because I can decipher it. All right, and I could see all that work all within 1. Does that all make sense? But here's the problem. What is this now? What is this now? This is a 1 over cosine. This is a 1 over sine over sine. Does anyone know what this becomes? 1 over cosine squared. Now again, I'm blowing the brain gaskets of those that do not have fractions well. If you don't know that, then you would have to add a separate step. You would have to add this in here, not off to the side. It would have to be step 2, and then this would be step 3. You would have to add, there it is, 1 over cosine t, maybe divided by cosine t, and then, make that times 1 over cosine an extra step. But I really would prefer that you know this real fast. All right? And then minus 1 over, I'm blabbering now. Okay, so what do we do next? What's next? Look at the right side, look at the left. What do we write? If you flip these, then this is secant squared. Not flip them, that's what the identity is. And this is cosecant squared. Lo and behold, we have this. Now, depending on the individual, like I said, you may have a couple extra steps in here to describe and understand what happens with that fraction work. All right, so there can be more, in this. I want you to try to shortchange this as much as possible. Okay, I'm not going to ask you any more questions. What in the world just happened there? All right, we're just going to go ahead and go from here. Now, why I know this one's a little bit more than this one, because I have 2 trig things. And then this, even though you're not allowed to do this, what is 1 minus cosine squared? So if I can get this to be sine squared, then I can turn it into 1 minus cosine squared. This is how your brain has to think. You have to look left, right, left, right. But I'm going to go ahead and do this. What's tangent squared? Sine squared over cosine squared. Well, I'll be darned. Times cosine squared. And then for neatness purposes, for satisfying Mr. Samuelus, put a big fat equal sign to denote a step or a number 1 or both. Okay, now what do I do within this step number 1? Now guess what? This says sine squared over 1. You could literally write the next step. We don't even have to write this. Sure, I know this. I don't really need this. Because what is sine squared? What did we just say sine squared is? No, it's not cosine. It's what? 1 minus cosine squared. And again, to satisfy Mr. Samuelus's needs, you will write this equals itself as the last step. You will not shortchange me a step before. It's one little extra writing. Nestor's getting ready to leave. Oh, I said his name online. He'll be an internet legend. Did you know that secant is what? What's secant? 1 over cosine. Did you know cosecant is what? And then those that are fractionally challenged, yeah, I say it, I get mean, then this is what you'd have to write next. This is the same thing as cosine of A divided by 1 over cosine times cosine. Oh, wait a minute. This isn't going anywhere. This is wild. By the way, I changed the alphas to A's, right? What's cosine times cosine? I should have just wrote that, but so I guess I'm forcing myself to write it. This is weird. What am I supposed to get? What am I supposed to get? Okay, now, do you know what this is? Do you know what this is equal to? This is actually equal to 1. Don't do it! You can't mess with the right side. So you know what cosine squared plus sine squared is? 1. Do you know what 1 is equal to? No, you know what 1 is equal to? What? What's 1 equal to? What's 1 equal to? No one's saying it. That's the structure you must follow. You must. See me after class, student number, what is this?